Hello everybody, this is Dr. Mubadsha. Today's lecture is about orthogonal trajectories. So first we talk about what are orthogonal trajectories, then we'll be talking about how do we find orthogonal trajectories. So orthogonal trajectories are basically, these are the family of curves which are intersecting the curves and they are perpendicular to each other. For example, in this figure you see there are some curves जिसमें आप एक ये कर्व है आप देख सकते हैं, दिस इज़ द वन कर्व, दिस इज़ द अनदर कर्व. ठीक है, अगर ये कर्व दोनों क्या हों, इफ़ दे आर परपेंडिकुलर, तो आपको ये पता होना चाहिए कि दो कर्व के बीच में हम एंगल कैसे फाइंड करते हैं और उनको हम देन हाउ डू वी चेक वेदर दे आर ऑर्थोगोनल और नॉट. जिस पॉइंट पर ये दोनों कर्व आपस में इंटरसेक्ट करते हैं उस पॉइंट पे हम टेंजेंट लाइन ड्रा करते हैं, एक कर्व को भी और दूसरे कर्व को भी. फिर इन दोनों कर्व्स के बीच में जो एंगल होती है दैट इज बेसिकली द एंगल बिटवीन दीज कर्व्स. सो इफ दिस एंगल इज 90 वी से दैट द कर्व्स आर ऑर्थोगोनल. So in case of orthogonal trajectories, what do? We will be given one family of curves which will be represented by some equations like y is equal to c something like that, e power x, या हमारे पास होता है y is equal to c x square. एक्सपोनेंशियल फैमिली ऑफ कर्व्स हैं और ये हमारे पास पैराबोलिक कर्व्स हैं. ओके, so if you want to find orthogonal trajectories for this one, so there is a procedure by which we do this. Okay, so let me first explain the procedure. There is an example as well. The procedure is if we are given a family of curves, like in this case, let's suppose we have given y is equal to some function of x and c, where c is an arbitrary constant. Okay, so what would you do? We first find a differential equation which will be representing this family of curves. Okay, it might be of the form dy by dx is equal to a function of x, maybe g of x, right? So once we have found that, that's the family of curves which represent this is a differential equation which represent a specific family of curves. Okay, या इसको हम वही चीज़ है कि इसको हम फॉर्मेशन ऑफ डिफरेंशियल इक्वेशन भी कहते हैं कि हमने डिफरेंशियल इक्वेशन को कैसे फॉर्म करना होता है. अच्छा, so once we have this differential equation, so for orthogonal trajectories, what do? We replace this dy by dx is equal to g of x in the form minus 1 over g of x, right? Or we may do that minus d by dx by dy is equal to g of x. या तो हम उसके राइट हैंड साइड को क्या करते हैं, रिप्लेस कर देते हैं माइनस वन ओवर जी ऑफ एक्स से, या फिर उसके लेफ्ट हैंड साइड को हम रिप्लेस करते हैं माइनस डी एक्स बाई डी वाई के साथ. दोनों में किसी एक का रेसिप्रोकल लेना. एंड द फैक्ट बिहाइंड दिस इज व्हाट, व्हाई डू वी डू दैट. जब हम कहते हैं कि एक लाइन और दूसरा लाइन इफ दे आर परपेंडिकुलर टू ईच अदर, इफ देयर इज अ 90 एंगल, तो इन दोनों के जो स्लोप हैं, इफ दैट इज m1, if this is m1, where a slope of this line if that is m2, right, the relation between slopes of these two lines will be their product will be minus 1. Okay, so m1 into m2 that should be minus 1. या in other words हम ये भी कह सकते हैं कि एक का जो स्लोप होगा वो दूसरे के स्लोप का नेगेटिव टाइम रेसिप्रोकल होगा. ओके, तो इसलिए हम क्या कर रहे होते हैं, बिकॉज यू आर इंटरेस्टेड इन द ऑर्थोगोनल ट्रैजेक्टरीज. सो इन दैट केस व्हाट डू? We are simply replacing dy by dx with minus dx by dy. Okay, you see in this case we are given an example x square plus y square that is equal to r square, which represent basically a family of circles with the radius r and center at origin. Okay, so in the blue color we are basically, we can plot them. So these are the circles with center at origin and different radii. अच्छा, अब इसका जो orthogonal trajectories हैं, they are basically what? They are straight lines. Or vice versa, if you consider straight lines passing through the origin having different slopes, तो उनकी जो orthogonal trajectories होंगी वो circles होंगी. Now, how do you find that? So the question is this, okay? So एक हमारे पास है lines y is equal to mx, कीपिंग इन माइंड यहाँ पर m जो है वो एक आर्बिट्री कांस्टेंट होगा. ठीक है, तो फर्स्ट हम यहाँ से डिफरेंशियल इक्वेशन को फॉर्म करेंगे. डिफरेंशियल इक्वेशन फॉर्मेशन का कंसेप्ट ये है कि अगर किसी भी फैमिली ऑफ कर्व्स में या फंक्शन में हमारे पास एक आर्बिट्री कांस्टेंट है, तो आपने उस फंक्शन को एक बार डिफरेंशिएट करना है, उसकी डेरिवेटिव फाइंड करनी है और फिर उस आर्बिट्री कांस्टेंट को आपने एलिमिनेट करना है. ठीक है, अगर इसमें दो आर्बिट्री कांस्टेंट्स हैं तो ऑब्वियसली आपने उसको दो बार डिफरेंशिएट करना होता है. सो इन दिस केस इफ यू डू दैट, हमारे पास जो फंक्शन है वो y इज इक्वल टू एम एक्स है. अब इसकी फर्स्ट टाइम हम डेरिवेटिव फाइंड करेंगे, सो y डैश विल बी सिंपली इक्वल टू m, because derivative of mx will be m. Now putting this value of m here, so we get what? We will be getting y is equal to y dash into x. Okay, ये y dash नहीं है, y है, सॉरी. अच्छा, अब यहाँ से अगर हम इसके लिए डिफरेंशियल इक्वेशन को फॉर्म करेंगे, तो द डिफरेंशियल इक्वेशन विल बी y डैश इज इक्वल टू x divided by y. This is the differential equation which will represent these straight lines. Okay. अच्छा, अब अगर इसी के हमें orthogonal trajectories चाहिए, so equation तो हमारे पास आ गया है dy by dx that is equal to x by y. That's the differential equation which represent these straight line in the red color. अच्छा, now if you want to find orthogonal trajectories, for orthogonal trajectories what do? We take dy by dx that is equal to minus y by x. या तो आपने उसके नेगेटिव टाइम लेफ्ट साइड को रेसिप्रोकल लेना है, या आपने राइट साइड का नेगेटिव टाइम रेसिप्रोकल लेना है. ओके. अच्छा, अब हम क्या करेंगे? वी नीड टू सॉल्व दिस डिफरेंशियल इक्वेशन dy by dx that is equal to, let me check this equation again if I have done this correctly. Y is equal to mx, so if you differentiate y dash is equal to m, so we have x y dash is equal to this one. Okay, so this is not y, x by y, it's y by x. Yeah, that's what I was looking for, because you just divide this over there, so it will be y by x, not x by y. So this is the same thing here. We have made a mistake. So you see, this is y by x, not x by y. But when you find the orthogonal trajectories, we'll be taking what? We will be taking this one as minus x by y now. So we got another differential equation. Now this differential equation will be solved in a following way. It's a separation of variable method. So we have y dy is equal to minus x dx. So to solve this differential equation, what do? We simply multiply this with 2. This one is 2 and this is also 2. And then we integrate on both sides to get solutions. So y square is equal to x square plus some constant c. This is minus x square. Or we could simply write this equation as okay. So you see that y square is equal to minus x square. That means x square plus y square is equal to c, which is representing circles. Okay, the blue color circles are represented by this equation x square plus y square is equal to c, where we this might be c1, sorry. So you see that is the radius of the circle is, okay, ये जो है ये radius of a circle होता है. So we can write that in this form as well, x square plus y square is equal to r square. Okay, so let me do some practice question now. Okay, so the first question is saying y is equal to x square plus c. So we want to find the orthogonal trajectories for this function or this family of curves. So we first find y dash. So y dash, that will be 2x, and then we have plus 0. Derivative of c is 0, or we could write that y dash is equal to 2x. Now this is a differential equation which is representing this family of curves. ओके अब इसमें कोई c मौजूद नहीं है, तो इसमें ऑलरेडी c जो है वो क्या हो गया, एलिमिनेट हो गया. So for orthogonal trajectories, what would we do? We will be taking the reciprocal of the right side. So we will be having dy by dx or dy dash, that will be minus 1 divided by 2x. Okay, where this could be simply solved. It's a new differential equation which is a separation of variable. So we will be having dy okay, so dy, that is equal to minus 1 by 2 into dx by x. Integration on both sides, that will give you what? That will give you y is equal to minus 1 by 2 into log of x plus some arbitrary constant c. So that is the family of curves which will be orthogonal to the given family of. अब ये क्या है हमारे पास, अगर आप देख लें तो ये पैराबोलाज हैं. किस टाइप के पैराबोलाज हैं ये पैराबोलाज जो कि शिफ्टेड पैराबोलाज हैं. दे कुड बी लाइक राइट, दिस वन, ये वाला हो जाएगा, ये वाला हो जाएगा, ये कुड बी एंड दिस वन इज वेल. और यहाँ पे जो इसके कर्व आ रहे हैं वो माइनस लॉग ऑफ अंडर रूट एक्स है या माइनस लॉग ऑफ एक्स बाई 2 है. दे आर लॉगरिथमिक फंक्शन. सो यू नो लॉगरिथमिक फंक्शन समथिंग लाइक दैट. इस तरह से कर्व बनेंगे. इट्स माइनस 1 बाई 2 लॉग ऑफ एक्स. लॉग ऑफ एक्स का जो ग्राफ होता है वो ऐसे होता है यूँ, और फिर जब माइनस का करेंगे तो आपके पास सिर्फ ये है कि ये यहाँ पर रिफ्लेक्ट हो जाएगा. सो इट विल बिकम समथिंग लाइक दैट. यूँ बनेगी इसकी. Okay, so the orthogonal trajectories are y is equal to minus 1 by 2 log of x plus c. Okay, if you see the second question is again, we are given a function y is equal to cx. So we would first find its derivative because we are having one arbitrary constant. So the derivative will be what, that is c, which is very similar to the equation we have solved earlier as an example, that was y is equal to mx and we are having cx. So you just go back and see that example. I've done that. Okay, so don't need to do this again. The next one is xy is equal to c. So this might be directly differentiated applying product rule. So we have xy dash plus y, that is equal to 0. Okay, and then you can write that in the form dividing by xy or whatever. Can I write this as y dash is equal to minus y by x? Okay, so minus y by x, that is a differential equation which will be representing these rectangular hyperbolas. Okay, so this is a differential equation. अब इसके बाद हमने इसकी orthogonal trajectories को find करना है. So for orthogonal trajectories we will be taking dy by dx, which is the y dash, and that will be replaced with x by y, जिसको हम solve कर सकते हैं. It's y dy is equal to that equals x into dx. Again we could multiply 2 on both sides, and as we did in previous example, and if you integrate this one, that would give you y square is equal to x square plus c1, or we may write that as y square minus x square is equal to c1, जो कि हमारे पास क्या है, हाइपरबोलास हैं. तो ये भी हाइपरबोलास ही होंगे. तो रेक्टेंगुलर हाइपरबोलास एक्स वाई इज इक्वल टू सी, ये इनकी जो ऑर्थोगोनल ट्रैजेक्टरीज हैं, दैट इज वाई स्क्वायर माइनस एक्स स्क्वायर इज इक्वल टू c1. Okay, if you go to question number 4, so in question 4, y is equal to y is equal to c by x square. So y dash, that would give you minus 2c divided by x cube. दिस अब देखिए, इसमें हमने ड्राइवर टू फाइंड तो कर लिया, लेकिन अभी c एलिमिनेट नहीं हुआ है, तो इसको हम एलिमिनेट कर सकते हैं, माइनस 2/x इंटू सी बाई एक्स स्क्वायर। जो c बाई एक्स स्क्वायर है, इसको हम वापस y के बराबर ले सकते हैं। सो वी आर हैविंग डिफरेंशियल इक्वेशन ऑफ द फॉर्म y डैश दैट इज इक्वल टू minus 2 by x and c by x square is equal to y, so we get this equation. And then for orthogonal trajectories, what would we do? For OT, we will be taking like dy by dx, dy by dx will be taken as, it was minus 2y by x, it will become now x by 2y. And then by separation of variable, we can have 2y, okay, that's 2y into dy 2y dy, come on, 2y dy, that is equal to x dx. And when we integrate this, that would give us y square is equal to x square by 2 plus some arbitrary constant c1, which are again hyperbolas, right? So the next one is y is equal to under root x plus c. So first we would be constructing a differential equation which represent this family of curves. So this would become 1 divided by 2 under root x plus c. Now we want to eliminate this one, so you see x plus c under root is what? That is equal to y, so we are having 1 over 2y. So we have a differential equation dy by dx that is equal to 1 divided by 2y. And then for orthogonal trajectories, we will be taking dy by dx that is equal to minus 2y, just taking the negative time reciprocal of it, okay? So, and then we solve this new differential equation. It's dy by y that is equal to minus 2 dx, which implies log of y is equal to minus 2x plus again another constant c1. Or we could write that as y is equal to e power minus 2x plus c1, or we may write that as e power 2x into e power c1, and then we replace this e power c1 with another arbitrary constant, so that would give you y is equal to a e power minus 2x. So these are the orthogonal trajectories for a given function. Okay, if you see the question, if you see question number 6, in this case again, I'll just construct a differential equation for it. Okay, let me make a separator so that there is no confusion. Okay, so if you differentiate, because it involves again one arbitrary constant c, so we'll be differentiating this one time. This implies y dash will be minus 2 xc e power minus x square. Now we see 2c xc square is y, so we get a differential equation like 2xy. So y dash is equal to minus 2xy is the differential equation which represents this family of curve. And then for orthogonal trajectories, for OT we simply take y dash that is equal to minus 1 by 2 xy. Okay, that is xy. And this differential equation can be solved again by using separation of variables. Okay, so I just gave you this as a homework to you. Okay, so let's go to the next one. So this is x square plus y minus c square is equal to c square. So these are the circles whose center is at y-axis and radius is c square. And there is only one arbitrary constant in this case, again c. So first what do? We simply expand this square, x square plus y square minus 2cy plus c square is equal to c square. We may cancel these two together. So we get x square plus y square minus 2cy is equal to 0. Now to find the differential equation representing this family of curves, it is a one arbitrary curve, so we will differentiate this first with respect to x and then eliminate what c from it. So that is 2x plus 2y into y dash minus 2cy dash is equal to 0. Okay, this could be written as dividing by 2 throughout, so we get cancel these two, and very simply now we have to eliminate this c from these two equations. So we have x y into y dash plus c y dash is equal to 0. From here we'll be having x plus, we can see y plus c into y dash is equal to 0. Now we need to find the value of c, which could be found from this equation. Okay, so if we see x square plus y square minus 2 cy is equal to 0. अच्छा, यहाँ से हम y की वैल्यू निकाल भी सकते हैं by using different techniques, या हम यहाँ से c की वैल्यू, सॉरी, तो I may write this one as c is equal to x square plus y square divided by 2y. Now putting this value in this equation, यहाँ पे जो हमारे पास आ रहा है इसमें पुटिंग करेंगे. Okay, so we get x plus y, and c will be replaced with x square plus y square divided by 2y is equal to into y dash is equal to 0. Okay, that's the. Now it could be simplified as well. Further simplification can be done. Okay, so that is x plus we see 2y square plus x square plus y square divided by 2y into y dash is equal to 0, or we could write that in the form, if we take LCM of this one again, so we get 2xy plus x square plus 3y square divided by, sorry, it's my fault, it's not like that. You will just take this x to the right side. Okay, to get what, wait for a while. So this is 3y square plus x square divided by 2y into y dash is equal to minus x. where we could multiply this on the right side to get this is multiply by 2y. So the differential equation becomes, let's do if I could get another one. Okay, so we have a differential equation now, which was x square plus 3y square divided by plus 2y is equal to minus x into y dash. So the differential equation becomes y dash is equal to minus 2xy divided by x square plus 3y square. So altogether differential equation will become y dash is equal to 2xy divided by x square plus 3y square. Square. Now for orthogonal trajectories, what would we do? Y dash would become x square plus 3y square divided by 2xy. Okay, and then we will be solving this equation, which is homogeneous equation. So we will take as to solve this equation now. You see this one. We'll be taking y is equal to ux. I hope you remember this from homogeneous equation or reduction to separable. So it will be y dash is u plus x u dash. So putting these values here, u plus x u dash, and then we have x square plus 3 u square x square divided by 2 x into ux, and this could be simplified. Then I may ask you to complete this one then by taking x square common from there. So we'll be getting 1 plus 3u square divided by 2u, and then it's a separable, and it will give you simply the solution of the new differential equation. Okay, let's talk about this example, which is application of orthogonal trajectories. One of the example is the application of the orthogonal trajectories is electric field, and obviously we talk about electric force or magnetic field. So they are basically what they are perpendicular to each other. So if the streamlines of electric field are given as circles whose center is at the origin and a radius is under root c. So what would be the orthogonal trajectories? Okay. So the concept is very simple, straightforward. What do? We are given the equations x square plus y square is equal to c. So we first find the differential equation which is representing this family. Okay, so that is 2y into y dash is equal to 0, or y dash, which will be minus x by y. Okay, this is a differential equation which represents this family of curves. Now for orthogonal trajectories, what do? We will be taking y dash that is equal to y by x, जिसको हम आसानी से सॉल्व कर सकते हैं. That is dy by y is equal to dx by x, and then this will give you log of y is equal to log of x. दोनों में log हैं तो जो arbitrary constant होगा c1 के साथ भी हम log ले लेते हैं. Okay, and then this implies that uh, log of y is equal to log of cx. This implies y is equal to cx, c1x. So these are the orthogonal trajectories. Mean to say, अगर हमारे पास जो स्ट्रीम लाइंस हैं अगर वो सर्कल्स हैं, ठीक है, तो जो इसकी ऑर्थोगोनल ट्रैजेक्टरीज हैं दे विल बी स्ट्रेट लाइंस पासिंग थ्रू द ऑरिजिन. यहाँ से जो भी स्ट्रेट लाइंस, तकरीबन ये वही एग्जांपल हम रिपीट कर रहे हैं, लेकिन वहाँ पे जो एग्जांपल था उसमें हमें स्ट्रेट लाइंस गिवन थे और हमने सर्कल को फाइंड किया था. अभी सर्कल गिवन है और हम स्ट्रेट लाइन को इस केस में फाइंड कर रहे हैं. सो ऑर्थोगोनल ट्रैजेक्टरीज, अगर हम ये कह सकते हैं कि अगर इलेक्ट्रिक फील्ड की जो एक पोटेंशियल लाइंस हैं, इलेक्ट्रिक पोटेंशियल लाइंस अगर वो स्ट्रेट सर्कल हैं, ठीक है, कंसेंट्रिक सर्कल्स हैं, तो उस केस में हमारे पास जो मैग्नेटिक फील्ड होगा या जिसको हम electric force कहते हैं, that would be what? That would be straight lines passing through the origin. Okay. So thank you very much for watching this video. If you have any question, uh, you can ask. You can just drop a message in the comments. I'll get back to you. So thank you very much, and subscribe to the channel so that if I just upload a new video, you get the